Hey guys,
Yo, what's up, Danish?
Oh, hi, Vish.
what are you doing?
Oh, we're just studying for the upcoming test.
Oh, on what topic?
Right now we're on differentiation, but I just
It's
think
really hard.
we can't get to.
It's okay guys, I can show you how. Alright, we'll start off with question number 1. So question number 1, explain the meaning of differentiation and what are the techniques of differentiation. So differentiation is derivative of a function y fx, derivative dy over dx represent the slope of the tangent to the curve at any point. So these are the technique of differentiation. So the first technique is the power rule. These are the formulas. D over dx, x to the power of n is equal to n x n minus 1. These are the example x to the power of 5. So the second rule, we have the product rule. So these are the formulas. D over dx, u v is equal to u v prime plus v u prime. And the example is x to the power of 3 minus 1, 3x to the power of 2 plus x. So the third one, we have question rule. D over dx, u over v is equal to v u prime minus u v prime over v square. So this is an example, 1 minus 2x over x square plus 3. The fourth one, we have chain rule. So chain rule, these are the formulas for chain rule. D over dx, f gx is equal to f prime gx, g prime x. So 5x plus 3 to the power of 5. Finally, we have the implicit differentiation. This is used when y is not isolated. So these are the example, x squared plus y squared plus 2y minus 3x plus 5 equals to 0. So that's it for question number 1. So do you guys know about the rules now?
Yeah, I get it now. But can you help me with this question, Danish?
Oh, this question, my friend Ivan know this one.
Okay, for the next question is question number 2. I'll be explaining for the question number 2. Okay, for question number 2, it asks find dy over dx for the following functions. And for the equation, it is 5x cubed tangent over x plus 2. For this question, we'll be using the product rule, which is u multiply v prime plus v multiplied by u prime. Okay, for the u, we'll be take out the 5x cubed, and then after differentiating 5 into number 3, multiply by 3, it will be 15, and 3 minus 1 will be 2. So the answer will be 5x squared. For the v, we got tangent x plus 2, and after v prime, tangent after differentiating, it will be secant squared x plus 2 and multiply by 1, because x plus 2, after differentiating 2, it will become 0 and x will be 1. Okay, and then after simplifying, the final will be secant squared x plus 2. So when we combine by using product rule, we'll get 5x cubed multiply secant squared multiply secant squared x plus 2 plus tangent x plus 2 and multiply by 15x squared. So, moving on to the next question. The big question asks for y equals to sine x over 2 minus 4x. For this question, we'll be using the quotient rule because there is a division. Okay, when we separate it for sine x for u and 2 minus 4x for v. So sine x after differentiating, it will be cos x. And for v, 2 minus 4x after differentiating, it will be minus 4 because 2 is equal to 0 and negative 4 over negative 4 over x, it will be negative 4. Okay, and when we transfer it to the quotient rule, we'll get 2 minus 4x over cos x minus sine x over negative 4 over 2 minus 4x squared. And then we'll get 2 cos x minus 4x squared plus 4 sine x over 2 minus 4x squared. For the final answer after simplifying, we'll get 2 minus 4x multiply cos x plus 4 sine x over 2 minus 4x squared. Okay, that's all.
Oh, so that's how you do it. Wait, how about question 3?
I think I know this one. Let me explain it. Let's go. Alright, for question 3, we are given y ln 2x minus exponent for the power of 3x plus 1 and minus cos 4y equals to 0. So the question is asking us to find the dy dx using the implicit differentiation. So first of all, we have to separate these 3 into, as you can see here, I have separated into A, B and C, and then we have to differentiate them one by one. So for A, it is y ln 2x, and we need to use the product rule here. So we will separate them into two different subjects, so as in u and v, and then we differentiate the u and v separately. So for the u, the y turns into dy dx, and then for the ln 2x, ln, when it's differentiated, it becomes 1 per x, so we put 1 and then per 2x because that is in the ln, and then times 2 because of the 2x, so it becomes 2 per 2x, and then when simplified it becomes 1 per x. So down here we will put them together, so it's u multiplied by v prime plus v multiplied by u prime. So this is how it goes. Y multiplied by 1 per x becomes y per x, and then ln 2x multiplied with dy dx become ln 2x dy dx. And then we move on to b. B is exponent 3x plus 1. For b prime, the exponent doesn't change, so we only need to count the powered one. So the powered one comes out to 3, so we just multiply it with the exponent, so it becomes 3 exponent powered by 3x plus 1. For c, it's cos 4y, so when we differentiate the cos, it becomes negative sign, and then we have to complete the differentiate the inside as well, so it becomes 4 dy dx, and when put together it becomes negative 4 sine 4y dy dx. So at the bottom here we will just put them back like they were, how they were. So it's 1 per x plus ln 2x dy dx, which is the a that we got earlier, and then minus 3 exponent powered 3x plus 1, which is the b1 we got over here, and then plus 4 sine 4y dy dx, which is the c. Okay, and then we will just multiply and just put them in place. So for example, as you can see here, the dy dx, the one that has the dy dx, we put it on the left side, meanwhile the one that doesn't, we put it on the right. And then after we put them like that, we bring it out, and then after that we just put the remaining one back into the right side. So the final answer is dy dx is equals to 3 exponents powered 3x plus 1 minus y per x divided by ln 2x plus 4 sine 4y. That's all.
Oh, okay, I get it.
Wait guys, I'm having trouble with question 4. Do you guys know how to answer it?
Oh, let me do this one. Let's go.
Okay, so for this question, we are going to use linear approximation to estimate the value of 2 over say 80.99 minus 4 root of 80.99 to 3 decimal place. So for the first step, we are going to let x equal 80.99, which you will get from here, and then we are going to find the x naught, which is the closest integer value of x, which we are going to get 81, and then we are going to let x minus x naught, which we are going to get negative 0.01. And then we are going to find the fx, which is essentially this equation, but we replace 80.99 with x. Then we can simplify it to 2x to the power of negative 1 over 2 minus x to the power of 1 over 4. And then we can find the f prime of x from this, and we will get negative x to the power of negative 3 over 2 minus 1 over 4 x to the power of negative 3 over 4, which we can simplify it to negative 1 over set x to the power of 3 minus 1 over 4 root of x to the power of 3. And after that, we are going to use the linear approximation formula, which is fx approximately to fx naught plus f prime x naught multiplied with x minus x naught. We are going to take the things we have written before and put it into the formula, and we will get 2 over set 81 minus 4 root of 81 plus in parentheses negative 1 over set 81 to the power of 3 minus 1 over 4 root of 81 to the power of 3, and we are going to multiply it with negative 0.01. And after we solve this part first, we are going to get negative 25 over 9, and when we solve this part, we are going to get 31 over 291,600. And after we calculate this and we round up to 3 decimal place, we are going to get negative 2.778, which is the final answer.
That's all from us for 183. Bye.